Okay, well, when we last left our intrepid heroes, we were talking about Google Web Toolkit. So let's take a look at the code again. Your application begins in this phone bill GWT class, which is part of the client-side code. The phone bill GWT, it has three main responsibilities: create the widgets, lay out the widgets, and set the event handlers. And then that's all it does. And then it waits for the user to interact with the event handlers. And so when the event handlers are invoked, like when buttons are clicked, let's go back up to it. Here again, when the show phone bill button is clicked, the show phone bill method is invoked. Now, show phone bill interacts with the server. And as we saw, this is complicated. This is interesting. We'll say interesting. Because it's an asynchronous invocation. Because what it's saying is like, oh, listen, click the button, go off, start the interaction with the server in the background, because that could be slow. And so that happens in the background. This allows the user to keep interacting with the client while the interaction with the server is happening in the background. And so when we call the getPhoneBill method on the service, what we send it is this async callback that specifies two things. First of all, if there's a problem, what to do with that problem and how to represent that problem to the user, how to handle that problem to the user. But then also the happy path, it's like, well, when you have a successful invocation of that remote method, here's what you do with what was returned by it. And in this case, it prints out a description of the phone bill and puts it in an alert box. I want to dive into the code a little bit more to show you exactly how GWT ties together the back-end service with the front end. So, as we saw before, the service is called this phone bill service impl. It extends the servlet, which handles a bunch of the magic in terms of serialization, in terms of communicating between the client and the server. And it implements an interface called phone bill service. Okay. Phone bill service extends something called remote service, which is just a tag service, a tag interface that says, "Oh yeah, right, this is a GWT remote service." You annotate your remote service with a remote service relative path, which tells GWT how to construct the URL for this service. Because at the end of the day, the communication between the browser and the server, it's HTTP. There's nothing special or GWT specific in the protocol that it uses to communicate. What is special and unique about GWT is what this client-side JavaScript does to create the text that goes over HTTP. And what's also special is what happens on the server side when the server side takes that text that comes in over HTTP and turns it into Java objects that are then delivered to your service. This interface then specifies all the methods of the service, like getPhoneBill, and we see that it's implemented. Excuse me. In the phone bill service impl. And then there's other things that show what happens when exceptions are thrown. But we're going to focus on getPhoneBill. So this is all on the this is all that's happening on the server side, even though the service interface needs to be in the client code, and we'll see why in a little bit. So this is what the back end, this is what the server side code does. Client side code is a little different. So the client side, here in the show phone bill method, it invokes, it uses something called the phone bill service. And this phone bill service has a getPhoneBill method, but instead of it taking 0 arguments, like the one on the server side does, it takes one of these asynchronous callbacks, these async callback objects. So let's see where this phone bill is defined. For every server-side service interface, you need a client-side async interface. The naming convention is to have it be like, whatever service you're doing, async. And this has a very similar set of methods to the server side, to the server side phone bill service, except that all of these, all of the client side methods return void, because remember these are asynchronous, right? It calls the method, goes off and starts something in the background, and then returns immediately. There's no result to return, right? So it's a void method, okay? No result to return. Things are happening in the background, and then when things stop happening in the background, when the result is returned, it is delivered to this async callback object. And all of this stuff it happens underneath all of the invoking the service in the background and handling all of the data and the possible exceptions and sending it to the async callback. That's all taken care of for you by GWT, by the GWT libraries and framework. So let's see here. Does this thing actually have? Okay. So this is an interface, and this interface itself is not. There's no class that you see that implements this interface. Instead, you get the following. So here we have a field that contains the async version, and this guy is initialized here. Okay, remember this is client-side code that we're looking at. This is the phone bill GWT. How many of you guys watched the reflection lecture? You guys remember what Java reflection is? What's Java reflection? Yes.
To be able to look at a reference and figure out what actual class it is.
Yeah, so it's an API that allows you to inspect objects at runtime. And so you get an object. It doesn't matter what kind of object it is. You can ask it, hey, what are your methods? And oh, hey, give me an object that represents your class, right? The class, right? That's the reflection lecture drinking game. Every time I say the word class, take another drink. Right? You're college students, you do things like that. Anyway. And reflection is cool because it's kind of magic, right? You can do things like just like taking a string, which is the name of a class, and poof, give me an instance of that class. It's got a zero-grammar constructor. Wow, this is amazing. You can just have very dynamic code. GWT has a similar piece of magic called gwt.create. So gwt.create is a method where you give it a class reference, right? So name of a class and then .class. And then it instantiates an object that implements the phone bill service interface. It invokes that, It creates an object that implements the asynchronous version of your phone bill service interface. And it ties it together based on that naming convention. Underneath the covers, it does all sorts of cool things about figuring out what the URL is and all that. You don't need to know about that. What you do need to know is that this is a little piece of magic. And remember, this is all happening on the JavaScript side at runtime. Right? This is JavaScript code that will give you an object that implements the async interface on which you can then invoke the methods. So that's what you've got there. So for your project 5, one of the things that you'll need to do is to expose back-end functionality like adding a phone call to a phone bill, printing a phone bill. I suppose you could do that on the client side too. Searching, all that stuff is implemented on the back end and is exposed to the front end versus methods on the service. So you need to add methods to your service to do the cool stuff that your application does. And that's all part of the assignment, is figuring out how this client-server communication works in GWT. Any questions there? Yeah, but
do all of these phone bill service async, all these other interfaces, are these handwritten or are these generated as like native generated?
There is a way to do that in Maven. It's really not that hard though to do it or by hand. And actually, IntelliJ has really good support for telling you, it's like, hey, listen, you added this interface method, but you didn't put it on your async. You need to put it on your async. Do you want me to put it on your async for you? Okay, poof, it'll do it and stuff like that. So yeah, it's It's for this project especially. It's only like 4 or 5 more methods they made to add, so it's not really a big deal. Yeah. Okay. Those are a couple of the fundamental things about your GWT project that you need to handle. So I've shown you how to debug the client and the server side. Any other questions before we move on to how to test it? Nope. Okay. So how to test this thing? Now, you've got you've got different kinds of well, like I said before, there are 2 different kinds of Java code in your GWT application. There's the client side and the server side, and everything's written in Java. And some of the Java code is just like plain old Java code that you're used to working with, like from projects 1, 2, 3, and 4. So like everything on the back end, right? And so it is just plain old Java code, so you can test it just like plain old Java code. So here I have a unit test for my phone bill service impl. And basically what I do is I go and I create one of these things. There's really no magic that needs to be created there. Just create one of those guys, call it get phone bills, and guess what? It returns a phone bill with 1 call. Okay, that's nice, and you can run it because it's just a plain old Java unit test. Nothing too special there. Yep. Yes. Stop debugging. Stop debug session. Thank you. And now when I run, okay, all tests pass. So that's nice because you can use all that unit testing skills that you've built up over the last 6 weeks to work on the back end of your GWT application. The front end code gets a little bit more complicated because if you look at your front end code, sure, you've got you might have some logic here in your front end. But you've also got a lot of GWT specific stuff that has like buttons and everything. And remember, this code is meant to be run as JavaScript. So if I just try to call this thing, it doesn't have a button, right? It goes to create one and it's like, wait, I'm not running inside a browser. What's going on here? So you can't just call these things as plain old Java objects because really they're meant to be run as JavaScript. So this tells you 2 things. One is that okay? And to cut to the, I'll reveal the punchline. You can test this code with unit tests, but they're really you can test this code with JUnit, but you run them as integration tests. And integration tests take longer to run than your unit tests because they have to do things like let's start the whole GWT simulation environment, great, and then run your code. Well, that's gonna be pretty slow. So the best thing for you to do, I don't necessarily expect you to do this for Project 5, but this is a good thing in general, is that you want to structure your code such that the important logic, your business logic of your application is independent of your view logic, independent of all the widgets and things like that. Because that way you can unit test, traditional, plain old, fast unit tests, all your business logic, and then yet you can have a couple of slower integration tests to really run it in the whole environment. I have a lecture on something called MVP, the Model View Presenter design pattern. I'm a big fan of it because it's really great at separating out your view logic from your business logic. It's not required for the course because it's pretty advanced and we're getting late in the term. But I recommend that you check it out, especially as you get more familiar with GWT and maybe as you start to realize, like, oh man, my integration tests are really slow. I want to be able to structure my code in a faster way. You'll be able to look at the MVP stuff and understand how all of that works. And if you're familiar with MVC, it's kind of a similar pattern and concept. MVP has some the way they distinguish the code and decouple the code. I like a little better. Anyway, so you've got your unit tests that run really fast. Let's take a look at the integration tests. So I have a couple of styles of integration tests. The first one tests the service. So I've got my service, and remember from the drawing here, my GWT, my phone bill service impl runs here in my servlet. And I want to have an integration test that lets me invoke those methods with, so I can send it various inputs or various stuff from the client. In this case, the client is an integration test. And unlike your project 4, where again you have to send a whole bunch of strings and stuff like that, the nice thing about this is that I can send objects its way and get objects in return. So if I go and hello. That's weird. Does my keyboard work? My keyboard's not working. Don't like that. Hello? Sorry, I completely lost my train of thought. I am going to... Okay, my keyboard's back. That was super screwy. I'm going to quit out of GWT mode, because now what I'm going to do is I'm going to run my Jetty sort of as normal. Oh, that's a different window. I don't want that anymore. It's the one I want. I'm going to say Maven Jetty. I'm actually going to do a Maven clean. Nah, don't do that. Yeah. One of the things in GWT is that I clean often, because sometimes, like when you do a Maven, when you just do like a GWT run versus, Jetty run more. I don't know, sometimes like the GWT plugin to Maven and the Jetty plugin to Maven don't always interact with each other nicely, so I end up cleaning a lot, and yeah, I have to rebuild things, but like if you find yourself in a funny state or like things are not working the way you should, quit everything and do a Maven clean, and that might help you out. Pro tip. Ding! Anyway, so what I've got here is I've got a test that goes and uses a library called sync proxy to basically give you a Java client to your remote service. So normally, it's the compiled JavaScript that interacts with your service. What this sync proxy library allows you to do is write Java code that acts against that same service, so you can test it more easily. And so this is one way to develop your backend service, is just to write an integration test against it. Okay, it started, so I think if I run it... Oh, there's a main? What is it doing? Sorry. Run it. I don't want to run the main. I want to play a game of chess. I wonder why it thinks that... Oh, wait. Yes, that's the one I want. Stop it! Thank you. That is not what I want. This is what I want. There we go. And everything passed. What this unit test does, this one is just making sure that it's that the server's up. This one basically does the same thing the Java client does, but the JavaScript client does, but is in Java code. So it gets you an instance of your phone bill service, and then you can call get phone bill on it, and then you can insert information about your phone bill. So this tests the service really nicely. And so that's good. That lets you exercise your service. But what you really want to be able to do is exercise your UI, right? So what you really want to be able to do is like interact with the UI. Now but you want to interact with it as Java code, so you can get interesting information about it. And that's what sorry, I'm looking for my test code. It looks like it's gone. That's what my phone bill GWT IT integration test does. So, is that yellow for a reason? Oh, yeah, okay. That's why. What this test does is it's a JUnit test that exercises my my main UI class, the phone bill GWT. So this is, and it runs it in this like browser emulation mode so that there are buttons there and you can interact with the buttons and it will do all of that stuff. So the way you do this is just treat it like Java code. You say, okay, I'm going to create my UI. I'm going to call my onModule method. And as you might recall, what this does is it ends up calling the setup UI method, which goes and creates all of your widgets and puts them in there. But instead of running in JavaScript like it does in the browser, this runs in Java code. Now, this is an integration test, and one of the things, this is an integration test of asynchronous code. So it's a little complicated because it means that you sometimes have to wait for things to happen in the background. Because here again, this is asynchronous, it's multi-threaded code here in the VM. So you've got your test that's running, and then it's saying, oh yeah, go start the UI. That happens in a different thread that happens in the background. So you have to wait for things to happen. So here I have there's a method that's inherited from this GWT test case class called wait before running, and so it says, hey, wait half a millisecond for before then clicking the show phone bill button. And what I then do is when so this clicks show phone bill button. Oops. And so then it will. Let me go and find it here. It will click this button, which will then invoke the click handler, which will then call show phone bill. This then makes a call to the back end. Right. This is all running in this emulation mode. Makes a call to the back end, gets the phone bill, and then prints it to and then does an alert. One of the things I haven't pointed out is that for testing purposes, I use this object called an alerter, which abstracts out the what actually happens on an alert, so that here in my test, I can use an alerter that captures the alert, the text that was alerted, the text that was sent to the alert. So then I can then interrogate it. I can say that, yes, the message contains the string that I expected. This unit test looks different from your other ones, right? It has to use these like wait before running methods, and you do your assert inside this like runnable method and stuff like that. And this is because you're dealing with asynchronous code, right? When you click show phone bill button, the click call returns before before the click has been handled. Because remember, the click when you click, you go and you call the server. All this stuff happens in the background, so you have to wait for that message to be displayed. So you just can't assert it right away. Instead, you have to wait for it to happen in the background. This is different from what you're used to. This is more complex than what you're used to, but this is how it works in the real world. Right? When you're dealing with a very fast computer and a very slow human, the interaction is asynchronous, right? And so very fast computer, very slow human, and a somewhere in between network, right? And so this is the thing that as you grow in your career as software developers, you'll be encountering more and more scenarios where there are lots and lots of interactions happening. And so sort of the CS 101 things that you can rely on, like my program starts here, it ends here, it's not like that. It's like you're swimming in the system, and data is coming in, and data is changing. And so you need to reason about, like, hey, what state is everything in, and how do things interact, and okay, what happens if this thing is down? It's why they pay us so much money, right? This stuff isn't easy. So that's how these tests work. And so as you can see, it exercises all the functionality here. I encourage you to test your interactions this way. I think it'll make for a very strong and hard application. You'll be very confident that things work. And so one of the things you might want to do is sort of like get all of the basic functionality in terms of like interacting with the back end, doing your query, doing all that stuff working first, and then make it pretty later. Or maybe you want to make it pretty first and then implement all the functionality. It's really kind of up to you. But you can certainly exercise and test all the functionality in GWT, which is one of the nice things about the framework. was a lot. I'll ask you a question, and I'll count to 30. What questions do you have before diving into your Project 5?
GWT stuff was because a couple of Google engineers didn't want to learn JavaScript.
Essentially so, yeah. So wait, come on. JavaScript's not so bad, right? The answer is yes. 10 years ago, though, JavaScript still seemed pretty bad. And so, yeah, this is like, Google that's got more money than God. They're like, hey, let's invent, let's write a Java compiler that outputs JavaScript. Woohoo, right? And yes. And as I was, saying at the beginning, it's kind of why it's fallen out of favor. It's, there's some complexities to it. Yep, it's kind of really neat, but one of the things two things have happened. One is that JavaScript has gotten a lot better. And like, ECMAScript and like, the new versions of the language, wow, it's much more usable than it is, but also then the implementations have gotten way more consistent. So, GWT came out, think back to like the first time you saw Google Maps and you're like, holy mackerel, how do they do that? And the answer, and people said, wait, you can do that with JavaScript? That's crazy. And so, Google said, wow, there's a lot of power that can be had with JavaScript, but it's really hard to do today. We want to hide all that complexity, so they had a handful of people come up with like this translation tool that takes Java, which everybody is familiar with, and turns into something that's less familiar, which is JavaScript, especially platform-dependent JavaScript. Back when, we still needed to support IE6, right? Which is the initial, right? That was reality, 10 years ago, and it's reality for some people today. Those poor people. But now, you've seen that there's sort of this steady evolution of better and better JavaScript, which has enabled more, which made it much lower barrier of entry into writing good, high-quality, professional JavaScript that can be developed with good software engineering techniques. Because that was the criticism of JavaScript, is that, it's a bunch of kids that are writing scrolly text, and it's not good for anything. Well, actually, there was a pretty powerful language there, but every browser implemented it differently, and it was just different enough from Java, and people were afraid of it. Well, people aren't afraid of it anymore, and so then today, that's right. I mean, I'd be very surprised if anyone's doing GWT professionally, but the lessons I want to teach you are the following. I want to teach you about asynchronous programming. I want to teach you about web user interfaces and user interfaces in general. And so this is the tool that I can use in an 8-week course. Were this a course? Okay, so if this was a course in user interface design or user interfaces in general, I would use a different widget set. And I'd probably then use something in JavaScript, and we would spend the entire class. The first 2 weeks would be, here's how to use the JavaScript or the modern JavaScript language, and here's how to use the libraries and stuff like that. That's not this course. Sorry. So it's basically either this or Swing. And yeah, no one. And Swing is like writing native applications, and no one does that anymore. Or if they do, it's or Java FX or something like that. Nope. I want something with the web. It's easier for me to test, and so we're using GWT. So, but GWT also, especially if you then dive into MVP stuff, it also allows you to understand more about user interface programming, and that is very applicable to Android programming. So if you look at, there are some things in Android that, were either influenced by GWT or it's like the same guys are talking to each other, because you can tell some of the concepts are very the same, are very similar. Okay, that was a long answer to a short question. What other questions do you have before starting Project 5 in earnest? Nothing? Okay, then. So, let's do a code kata. So a couple weeks ago, we did a kata, and actually I was pretty happy with the way it turned out. I think it was a good use of in-class time, so I'd like to do another one. I don't. What was the last one? I don't remember. Tennis, a game of tennis, right? Pretty straightforward. This one is Pac-Man. Everybody remembers Pac-Man, right? Hey, 1982, whatever. So here's what I'd like you to do. I'm going to post this on Google+. I'd like everybody to take 5 minutes, read this over, and think about a couple of things. Think about some of the scenarios that you would use to test your implementation of Pac-Man. And then also some of how you might design it, what some of the classes and methods might be. And then we'll do what we did last time. We'll find a partner and talk about it for 5 minutes. And then partners will find another set of partners, talk about it for 5 minutes, and we'll do a whole group thing. But first, we're going to start with some just thinking on your own. I'm going to post this on Google+. I'm going to pause recording.